Well, how's everybody doing?
Great. Pretty cool.
All right. You guys feeling comfortable with the compass error? Did you guys get some practice in over the weekend? Maybe. All right. Good, good. Good, good. We'll wait for a few more people to come on. Here we go. And today, during class, we're going to be working on the 1210 TR chart. So if you have your charts out, that won't be till the second half of class, but just so you know. Welcome everyone coming in.
Hello.
Hi. How you doing, Dave?
Good. How are you?
Good. All right. We got a few more. All right, we're getting our last few people in. Any questions from last week? We're doing all right?
I have one.
Yeah, go ahead, Milo.
I gotta find it now.
Okay.
It was on assignment 7,
Yeah.
number 19.
Yes, that's the fun one everyone likes to do.
Well, my first thought was just to add 180 degrees.
Yes,
but it didn't work.
You want to go on the overground on your true course. You have to convert it to true.
But if you start with a compass course and you want to return on a compass course,
so your deviation is different on each heading. If your deviation going one way is different than your deviation going the other.
So that's the real.
Yes, so you have to convert it back to true and then apply a new deviation if you're changing your heading.
All right. Okay. I thought I was missing something. I go, well, just add 180 degrees. So make it turn around. But
yeah.
All right. It makes sense now. And I knew I was missing something, but I didn't know what. Okay.
Yeah. And I did do that step by step on the tutorial video if you wanted to watch me do it.
Well, I got a different answer. So I go, why do you get a different answer? So I did the whole thing and then got the right answer.
Okay, good.
It made sense to me just to add 180 degrees.
Yep, but we got to go back to true.
I got you. Now.
All right, good. All right, well, before we get started here, I wanted to ask, someone logged in last week with their phone, and I wanted to make sure the attendance was right. Does anybody have a phone number ending in 8623? Anyone here? called in last week? Okay. Still looking for that person. Okay. Any other questions from last week's homework? Are you guys getting access to things or any problems with that anymore? You guys have the charts and plotting tools now? Everyone's kind of getting settled in?
Yeah.
All right, cool. All right. Well, I'm gonna put this away. And today we are going to get started on our 60D street or distance, speed, and time calculations. So we're going to focus on that calculation and then time, and then we're going to work on the chart. So we're going to be working on the training chart. That's the 1210 TR, but we'll have a break in the middle so you can bring out your charting, your plotting gear, or move to a bigger table or something. So let's get started. If we don't have any questions, we'll dive into this. Don't have it brought up. Hold on. Switched my computers here at the last minute, so now I got to bring it up again. Oh. All right, stand by for a second. Hold on. Okay, I'm back. Sorry. Okay, we should see the PowerPoint, right? Everyone sees it? Cool. Thank you. Let me get more people on here. We got a few more people here. Okay. All right, so today we're working on speed, distance, and time. I'm not going to review these skills just yet because I think with the videos and things, I think you guys are okay. So when we're talking about distance, time, and speed, these are our units of measurements, and we always go back to units to make sure that we are getting a correct number and we don't get some crazy big number or some crazy small number and it doesn't make any sense. If you know what units you're working with, then those numbers make a little more sense. So for distance, we're going to work in nautical miles. So a nautical mile is a little bit different than a statute mile. So remember that nautical mile is 1/60th of a latitude. Remember, we measure our nautical miles on the latitude side of our chart. So 1/60th of 1 degree of latitude is 1 nautical mile. So that's how the nautical mile has been invented, if you will. And then we have the statute mile, and that's the miles per hour you use on your car, kind of the American way of saying miles. So a mile is, statute mile is 5,280 feet, where a nautical mile is a little bit bigger. It's just over 6,000 feet. So that nautical mile is bigger. They're not exactly equal, but for everything on the chart and everything in the marine realm, we're going to be using nautical miles. So that might be a new term for us. And then we have time, and our time is either going to be in hours or minutes. It can't be both. So you're either in all hours or all minutes. So I understand, and we're going to go through this in the PowerPoint. You know, you can't have like standard 1 hour, 15 minutes. Can either be, you know, 75 minutes, or it can be 1.25 hours. So you need to, we're going to go over how to convert that time into hours or minutes. It can't be a combination of both. It has to be one unit of measurement. And then we're going to go over speed. So knot is a new term for a lot of us, but we're not going to, we're going to simplify it here. A knot is a nautical mile per hour. So your standard, you know, MPH, miles per hour, is with the statute mile. So when you're looking at a knot, it's just nautical miles per hour. So if you're converting it, I think some marinas have miles per hour speed limits versus knot speed limits. They are very similar, but a knot is going to be a little bit slower. Yes, 1 knot equals 1.15 miles per hour. So we have our nautical miles per hour is what a knot is. So it's just a fancy term for saying nautical miles per hour. And we're going to go over that in our formula. Any questions with the units? Do those make sense? Okay, cool. Okay, so we have 2 basic formulas when we're talking about distance, speed, and time. So our basic formula is D for distance, and we measure that in nautical miles, is equal to knot times time, or hours. So speed times time equals our distance. So if we were to go, you know, if you're driving down the highway and you're going 60 miles per hour in 2 hours, how far would you go? You multiply those and you get 120 miles. So it's the same kind of formulas. A lot of us do that in our heads, but we're going to work at it in nautical miles and kind of work from this formula here and mixing it around. So this first form, D equals ST, is for hours, but we're going to work a lot when it's in minutes. So we add this 60 in front of it so we can move our units around. So we have 60 times D equals speed times time in minutes. So it has to be a whole minute number versus hour or hour in minutes. So those are our 2 options. And I would say in my experience, commercial sailors, I would say, use the DST formula. Most, I would say 90% of my recreational boaters in this class use the 60 D Street formula. So from here on out, we're going to work with the 60 D Street formula, but I just wanted to put the base one here for you guys. But most of us use our 60 D Street. Okay, so how do we move this formula around? So if we have 60 D Street and we're looking for speed, that would be the S. How do we get, when we have a formula, we want the thing that we're looking for all by itself. And with the 60 D Street formula, we have 2 things on either side of the equation. So we need to move around the equation somehow, we're going back to those high school algebra classes of how we move things around an equation. So the rule for moving things around in an equation is doing the same thing to either side of the equation. So in this case, I would divide both sides by t. The t's cancel out on this side of the equation. The t is left over here. So I get 60 times d divided by t is going to give me speed. So even though that s was connected to the t over here, I basically moved that t over by dividing it to the other side of the equation. Make sense so far? Okay. That's our equation. Same type of thing, if we're looking for time, we're going to divide both sides by s. The s's cancel out, and we're left with 60 times distance divided by s to give us time. So this is that 60 D street formula. We're just working that around until we get what we're looking for. So each problem that we have, we might be looking for something different. So our last one is distance. How do we get distance by itself? Same thing. We divide by 60 on both sides. The 60s cancel out, and we're left with distance equals speed times time divided by 60. So those are our basic formulas. If the formula is too overwhelming, we have what we call a magic circle. A lot of people like this magic circle. It's circle with a cross in the middle. So you have 4 quadrants of the circle, if you will. And we're going to write in our 60 D street. So you'll start hearing me say 60 D street a lot. And that's our basic formula. 60 times D equals S times T. So for the 60 D street magic circle, the 60 and D go on top, and then the S and the T go on bottom. Now, the rules of the circle is you always multiply across first. So whatever, you're going to be missing one of these values, right? You have D, T missing S, or D and T missing D, whatever it is, you're missing one of these values, but you have 2. So whatever 2 that you have, you multiply across first. And then you divide by the one that's next to the one that's missing. And I'm going to show you an example of this if it doesn't make sense for the magic circle. So let's get into an example of it. But the rules for it is multiply across first and then divide by the remaining number to get your answer. So multiply across, then divide. Okay, so let's do an example, or I already have it out this way. I'll just walk through it. So our speed is 15 and our time is 30 minutes. How far did we travel? So if you're traveling at 15 nautical miles per hour in 30 minutes, how far did you travel? Now, just looking at this and not doing 60 D street, I'm covering it up, but I know you guys can see it. You might say in your head, oh, I know the answer to it because of whatever experiences that we've had. We can do that mental math, but we're going to lay it out so we know why we're doing this mental math. So we have 60 D street. I'm looking for distance, so I get that D by itself, and I'm left with D equals S times T over 60. I fill in my numbers, so I have my 15 and my 30, and then I just plug that into my calculator, and I get 7.5 nautical miles. So half of 15. If we're doing it in the magic circle, we put our 60, we have a question mark for the D, and then we have S and T. You always multiply across and then divide by the other number, which we had was 60. So you just plug that into your calculator and you get 7.5. So either way works, whatever way you're comfortable with. It's really the same way. It just, I don't know, looks a little friendlier in the circle. It has equal sign. Some people like that formula type and some people like the magic circle. Let's do another one. This time we're going to be looking for time. So we have a speed, we're going 8 nautical miles per hour, 8 knots, at a distance of 2 miles. How long will it take us? So we want to get that time by itself. So we rearrange our formula to get t by itself, and then we plug in our numbers. 60 times 2 divided by 8 gives us 15. So it'll take us 15 minutes to go the 2 nautical miles. Same type of thing with the magic circle. This time the 2 numbers that we have next to each other are on the top. So we do 60 times 2 and then divide by the remaining number to get our question mark. So that's our 15. Last one on both of these is we're looking for speed. So again, we are getting S by itself for speed, and then we just plug in the numbers and we calculate. With the 60D Street circle, magic circle, both of our numbers are on top, so we multiply the top first and then divide what we have left over on the bottom. And we get our 6.7. So that's both of those formulas. Take a little breather here. Does that make sense so far on the basic formula?
Yes.
Okay, we're gonna practice it together. But let's keep going. Okay. So where do we find this information? For distance, most of the time it's going to be measured on the chart. So if we want to go from point A to point B, how far is that on the chart? And we've practiced measuring distances. So we draw that line, check that line to make sure there's no hazards, right? As soon as we draw a line, we got to check it to make sure we're not running over land or any sort of hazards along the way or crossing a channel or traffic lane or something. So we always want to check. And then we can measure the distance using our dividers and then going to the side of the chart using the latitude scale to measure our nautical miles. Yards and meters, there are some weird charts out there that have yards and meters, so you want to make sure you know which unit you're measuring in. And again, we're always trying to get to nautical miles. I'm going to say 99% of the time your chart will be nautical miles, but there's just that on here. So time, again, is either hours and minutes, and we must convert. So we're going to practice that right now. But then for speed, it's knots, and that we're either going to find on our boat as like a speed logger. A lot of times we have what's our current speed or what's the past speed that we've done in the last 6 minutes or 12 minutes. If you have a Doppler speed log, it'll give you the current speed. And then we have a couple different types of speed that we'll end up talking about. We have speed through the water, speed over ground, speed made good. And again, we'll go over those, but all of our speed is always going to be in knots. Our formula for knots, again, is speed equals distance over time, just like miles per hour, your nautical miles per hour, just like on the highway. We just call it a fancy name of knots. So let's practice our time conversion. So this is going to be our next. We have a couple examples here. So if we have 1 hour and 15 minutes and we want to convert it into time, we can do it 2 methods. This is our first method here. We have 1 hour and 15 60ths if we're looking for the whole hour, right? Because there's 60 minutes in an hour. So that 15 minute is equal to 15 60ths of an hour. So if we divide that, it would equal 1.25 hours. Now, if you want to do minutes, you can do 60 minutes plus that remaining, that 15, to give you 75. So it all depends on you. Can you envision what 1.25 hours looks like in your head, or can you envision what 75 minutes looks like in your head? Again, we're not doing 1 hour and 15 minutes, which is what we commonly use in your day-to-day life. So we're going to either hours or minutes, whatever your preference. So this one is going to be an example of a large number. So if we have 6 hours and 36 minutes, we have 6 and then 36 60ths. So that's 36 60ths of an hour plus our 6 would equal our 6.6 hours. Now, if we were to do that with minutes, we would have to do our 60 minutes times 6 plus the 36, and we get 396 minutes. So here, again, is visualizing to help you, navigate on the fly, kind of looking at these numbers. The 6.6 hours or 396 minutes make more sense to you. Can you, calculate those or just envision what that number is? We always want to be looking at these numbers and being able to understand them and what they mean, and not just overwhelmed by all these numbers coming at us at our console. Okay, so last one is our 42 minutes. It is 0 on the hour section. So we're just 42 60ths of a minute, which is our 0.7 hours. Or super easy, we're just going from minutes, is 42 minutes is equal to 42 minutes. So most commonly in our recreational world, we are working with smaller times, whether it's within an hour, within 2 hours or 3 hours. We're not getting to that 6 hour or multi-day numbers where we get really big. So we're going to focus on using those minutes. So the 60 plus 15 or the minute section. So we're converting our time to minutes, and that's where we're going to use our 60 B street. Any questions with that? Does that make sense? Okay. Excuse me. Okay. Next up is going to be our adding and subtracting of time. So I'm going to go over our basic adding and subtracting, but instead of how we learned how to add and subtract time, we're not in that 10th scale really, where if something goes over 10, you carry the 1. We're in 60. So I always like to divide. I always like to put a line for the minute side and the hour side. We always start with the minute or smaller side. If you're in seconds, you start with the seconds. For this class, we're always going to be in minutes, or hours and minutes. So we're always going to start on the minute side. So I like to put a little line down the middle, and we're starting with this. So we have an addition sign. If we're adding 23 plus 12, we just add the minute side first, and then we add our hours. Our 11 plus 10 gives us 21 hours. So that one's pretty basic. I didn't start out, which I wanted to. All of our time in this class is going to be in military time or standard time. I don't know, there's lots of different names for it. What are other names for it? 24-hour time. It's where we don't have AM or PM. We have 1 through 24. So your 1 PM is the 12 plus that 1, 1300. Your 2 PM is 1400. It's 2 plus the first 12. So all of our times are going to be in that 24-hour time clock, if you will. So that 21, what did we just calculate? 21:35. Does anybody kind of calculate it real fast? What is it in AM or PM?
PM.
9:35 PM. When you start using it more and more, it starts getting second nature, and you start being like, oh, 2200, 10 o'clock, or it just, it becomes second nature. Okay. Anyways, so now we're going to be subtracting sometimes. So 2255 minus your 2035. You always start with the minutes and seconds. So we have 55 minus 35, 20 minutes. 22 minus our 20, 2 hours. So we always want to put, especially in our subtraction, the later time on top. So whether it's, you know, later in the day, later in the future, if that makes sense, we always want to put the later time on top. Meaning if we are dividing or subtracting, you know,
The greater time.
yeah, the greater time. Yesterday, I guess my point is that sometimes if you pass the midnight hour, the next number will be smaller, but it is the later time, or the greater one. So that's the one that always goes on top. I really butchered that. We want to put the later time on top. So in this example, we were, you know, maybe we departed Newport at 2035. We arrived someplace else at 2250. How long did it take us to get there? So we do that, that subtraction, and that's how we get our time. And then from this point, we either calculate to whole hours or whole minutes. So that is our subtraction. Now we get to when we carry a 1 or carry a number. For adding here, maybe we left at 15:45. It takes us about an hour and 25 minutes to get someplace. When are we going to get there? We always start with the minutes first. And 45 plus 25 gets 70. Well, 70 is not a minute that we can work with, right? We can only go through 1 through 59 or 1 through 60. So we have, how we deal with this is that we have to subtract 60 from this and carry the 1 over to this side. So we subtract 60 and we're left with 10, and then we carry the 1 on our hour side. So we have 15 plus 1 and 1 gives us 1710. So instead of giving 1670, we needed to convert it to a time that we can use, which would be 1710. Does that make sense? Okay. For subtraction, again, this is the later time on top. Maybe this is our departure, this is our arrival, when are we going to get there, or how long did it take? The later time is on top, and we always start with the minutes. So we have 12 minus 23. Well, we can't do 12 minus 23, so we need to borrow from the hour side. So we're going to make that 9, an 8, and then make this 12 a 72. So we took 60 minutes from the 12. We didn't make it 112. We had to add 60 minutes to it. So we're trying to change our habits of just adding a 1 and going on the tens and hundreds and thousands scale. We're on 60 for the hour. So we have 60 plus 12 gives us our 72. Now we can do our subtraction. 72 minus 23 gives us 49, and then 8 and 8, 0. So how do you guys feel about that so far? Okay, good. I'm glad you guys are doing good, because now I'm going to give you 10 minutes to do these questions by yourselves. So we have our ETAs. You depart at a certain time. You have your transit time. When are you going to get there? you have your difference between times, you know, arrival, departure, how long did it take? Or if you want to arrive at a certain time, you know what your transit time is, when should you depart? We have 3 different types of questions here, and I'm going to give you about 10 minutes. Holler at me at any point, and I'll do one on the whiteboard here. But go for it. Also, real quick, while you guys are working, we had some latecomers come in. Is anybody here phone in last week with the phone number ending in 8623? No, okay. Carry on.
I like that last one.
It gets harder and harder.
Sneaky captain out there. Got me for a second. That ain't gonna work.
We'll give you guys 2 more minutes here and then we'll look at the answers. All right. Any big questions? I'll show you guys the answers. Oh, I do it one at a time, but I think you guys. Okay, so Captain Ron mentioned it, but on the bottom, our ETDs here, we had the middle one, they're not numbered, I guess, the middle ETD. We had 1,400, took us 36 minutes to get there. So we had to borrow the 60 to subtract. We'd need to leave by 13:24. Now with the next one, we had, we wanted to arrive at 01:38 and it took us 1 hour and 46 minutes. So we, excuse me, 36, we can't subtract 46 from 38. My numbers are all mixed up. So we need to borrow and we're left with 0. And then we change that 38 to our 60 plus, so that would be 60 plus. Okay, that's 98. That's a wrong number there. But 98 minus 46 would give us 52. And then 0 minus 1, we can't do that. So our 0 turns into 24. And then we have 24 minus 1. So we need to leave at 23:52 in order to get there at the 01. So we're crossing that line where it goes from one day to the other, where it goes from the 2400 to 0 or 01. All right, you guys feeling good about that? Let's do assignment number 8. That was a little warm up. So I'm going to do assignment number 8 with you guys. It's the distance, speed, and time. It only has 6 questions. So I'm going to do it on the whiteboard. But if you guys get it out, you can do it along with me. So again, it's our assignment number 8. This one doesn't have number 8 on it for some reason. Distance, speed, and time. The first half of it goes over, your formulas. You can use each formula or you can move it around. And for this, we're always going to do our time in minutes. So we use our 60D street. Okay, so for number 1, they told us at 11.6 knots for 2 hours and 14 minutes, what was our distance? So this was our time, and this was our speed. and we need to figure out distance. Our first step is to convert that time to hours or minutes. So we need to convert that. That would be 2 hours. So it's 60 plus 60 would give us 120 minutes plus our 14. So we get 134 minutes as our time. So our time is now equal to 134. Our speed, 11.6. We're looking for distance. So we want to plug this into our formula, our 60 D street. We're looking for distance. So we want that D all by itself. So I'm going to do formula and then circle. So my formula would be D equals S times T divided by 60. Then you just move in. That T goes to the T, the S goes to the S. So we have D equals 11.6 times 134 divided by 60. Does anyone have a calculator?
$25.91.
25.9.
Yeah.
And that's nautical miles. We always want to put our units. My sloppy handwriting. Nautical miles. So that's our answer the formula way. If you want to do it magic circle, 60 D street, we can plug in, we have 60. We're looking for distance. Our speed was 11.6. Our time was 134. We multiply 11.6 times 134, divide by 60. So same thing that we did there, but that's how it'd work on the magic circle. Okay, any questions with number 1? Let's do number 2. All right, number 2 told us it took, so time was 1 hour and 22 minutes to cruise a distance of 18.6 nautical miles. What was our speed? So what was our average speed in that cruise? So we want to first convert the time into a unit that we can use, either hours or minutes. We're going to do minutes. So we have 60, right? That's the 1 hour. 60 plus 22. So that's going to give us 82 minutes. And our distance, and we're looking for speed. So our formula, we have our 60 D street. We're looking for S. So we have 60 times D divided by T gives us S. Plug in those numbers. 60 times a distance of 18.6 divided by a time of 82 gives us a speed. What does our speed equal?
13.99.
What did you get?
13.6 knots.
13.6 knots. That is our speed.
Yeah.
If we do magic circle, we have our 60. We have a distance of 18.6. We're looking for speed. And then we have a time of 82. The same type of thing, 60 times 18.6 divided by 82. All right, any questions on number 2? I know we're doing this quick, but let's do number 3. All right, we cruise at a speed of 14.3 knots for a distance of 24.6 nautical miles. How much time did it take? Okay, so how long will it take us to go 24.6 miles at a speed of 14.3? So time, we don't have to convert just yet because we don't have time. So for formula, we have 60 D equals ST. We're looking for T, so we have 60 times D divided by S gives us T. 60 times our distance, 24.6, divided by our speed, 14.3, gives us a time, and it's going to be,
minutes.
what was it?
103.2 minutes. An hour and
103 minutes. So now we need to convert that into hours, or hours and minutes. So we have 103 minutes. The easiest way to do this is just subtract 60. And we get 1 hour and 43 minutes. 1 hour, 43 minutes. And that is what our time is. So here we converted it afterwards. Same thing if we do magic circle. Our T would have equaled 103. And then we convert it, 1 hour, 43 minutes. Okay, so a little, I don't know, cheat sheet, if you will. You can see how you multiply two numbers and divide by one out of those 4 numbers that we have. So if you get a number that's like, what would have been in this one? Like 0.3 minutes or something, then you probably divided when you should have multiplied, or vice versa. So if you always want to do that, does this make sense? That common sense check of if I'm looking at it, does that number make sense? Would it, if I was going 14 knots at a distance of 24 miles, give or take, would it take me 5 minutes, or would it take me at least over an hour, maybe 2 hours? You kind of want to do that like mental, does this number make sense? Same with, you know, going the other way with speed or time. My point is, if you get a number that's just wacky, then you probably, you know, multiplied and divided, flip-flopped that. So just do it again in your calculator and flip-flop it the other way. We always want to do it, you know, by the book. But, you know, mistakes happen. We get, you know, airhead moments and we can't remember what the formula is or what Crazy Brie was talking about. So just play with the numbers. You're multiplying one and dividing the other out of the 4. So try to get a number that works, and most of the time that'll work out that way. But I will start saying this over and over again. That common sense check, does it work out? You know, it's easy to get the reciprocal of a course. And if I'm going north, I'm going to be, you know, in a very small number. If I'm going northeast and not a very large number. So we want to do, does it make sense kind of checks along the way. Anyways, okay. Let's do number 4. What speed are we making? If we go a distance of 21.4 nautical miles in a time of 3 hours. So on this one, we have it in whole hours. So we either use D equals ST and keep it in the hours, or we need to convert that into minutes. So that 3 hours would equal 180 minutes if we keep it into our 60 D street. Make sense? Okay. So I'll do our 60 D street. We're looking for speed. So we have 60 times distance divided by time gives us speed. 60 times 21.4 divided by 180. Here we go. 60 times 21.4 divided by 180 gives us a speed of 7.1 knots. Did anybody do it the D equals S times T? Okay.
If you took 21 divided by 3, you still got the same number.
Exactly. Exactly.
So we're allowed to use calculators.
Yes.
Not, we don't have to have an abacus on the boat.
No. You can use any sort, and you know, you can get real fancy and get one of those fancy celestial or nautical calculators that has knots in it for you and all sorts of stuff. But we want to make it easy for you. But yes, we're going to use calculators. Okay. Number 5. We leave buoy A at 0800.
Is there any trick about learning the 24-hour, like just besides just getting used to it? Is there, you know, one of those nice
Poems that I come up with.
yeah,
Silly poems, Breeze craziness. I don't have one for you. It's really just 12 added or 12 minus.
Okay.
So you're just adding or subtracting that 12. You know, if it's
and the middle of the night is 0.
correct. Midnight is 0.
0 dark 100, right? That's how
Yep.
they say it. Okay.
Yep.
Thanks.
Yep. Okay, so where is I? Buoy A, 0800, will be at buoy B at 1022. We have a speed of 8.6 nautical miles. How far are those two buoys from each other? So we need to get our units. So we have speed, we're looking for distance, but we need time. We were given 2 times, but we need to calculate what our T would be in the formula. So we always put that later time on top. So I have 1022 minus 0800. I start with my minutes. So I have 22 minutes. And then I go with the hours. I have 2 hours, 22 minutes. So I need to convert that all to minutes. So I have 120 plus 22 gives me a minutes of 142 minutes. So my time, where am I going to write this? My T is equal to 142 minutes. I have my speed. I'm looking for my distance. So now I can go to my 60 D street looking for distance. So I have distance equals speed times time divided by 60. My speed was 8.6. My time was 142. Divide by 60. What is my B?
Main point.
20.3 nautical miles. So if we were doing a magic circle, we have our 60, our speed is 8.6, our time was 142. We multiply the bottom there first. So we multiply and then divide. Okay, and we had practiced our adding and subtracting on time on this one. And then we had to convert that hours and minutes into whole minutes. That was a good one, wrapping it all up. Any questions? All right, let's do number 6.
Real quick, is there any, I know you're converting to minutes. If hours work better for us, is there any reason to convert to minutes, or can we just stick in hours with a decimal place?
Just stick with hours and decimal places.
Okay.
Honestly, that's what I do. And a lot of commercial mariners do that. And they tend to do things always on the 6th minute. So if you were to take arrival or take departure, even if it was at 12:05 or 12:04, you would call it 12:06. That way everything's a clean, 0.1.
Yeah.
And we go by those sixths, which are equal to tenths, essentially. So yes, either way is fine, whatever works for you. A lot in the recreational fleet, a lot of people like minutes, but hours, totally fine.
Cool. Thank you.
Okay. Number 6. There we go. We are at a local harbor at 10 o'clock. Okay. You want to cruise to a distant harbor and meet friends for lunch at 1300. The distant harbor is 19.8 nautical miles away. Your boat just came from shipyard and 5.8 knots is no problem. So you have a speed of 5.8 knots. Will you make it to lunch on time if you depart at 10? So what is our time if we need to travel this distance and this is our speed? And then we can see if we'll make it on time. I haven't been doing magic circle, so I'll do that one here. 60 DST. So we have 60, our distance is 19.8, our speed is 5.8, and our time is our question mark. So we multiply 60 times 19.8 divided by 5.8 gives us 200, we're going to call it 205 minutes. So 205, 205. And I also like to do this when I'm converting from a large minute to an hour. I'll just minus 60. I get a large number again. So that's 1 hour minus another 60. That's 2 hours, still over 60. So minus another 60 would give me 3 hours and 25 minutes. If I was to convert this 205 You can divide it by 60, subtract the decimal, and then multiply it by 60 again. There's lots of different ways to do it, whatever works best for you. But we get 3 hours and 25 minutes.
That's too good.
Yes, yes it is. So if we depart at 10 and it takes us 3 hours and 25 minutes, we start with the minutes. This is really sloppy now. 25, 13. The earliest we'd get there is 13:25. So we would miss our lunch date. So we need to either leave earlier or make better time. Make it faster speed. Okay. Any questions with 60 D Street so far?
All of this is dependent on a straight line.
Yes.
Which my boat rarely goes. I mean,
So yes, in this class, we're kind of learning the basics in this like ideal situation. And then in CoNav1, we go over tide and current and set and drift and how our, our fictional position was probably different than our actual position. But we're going to learn the basics in this ideal conditions, which is impossible. There's no ideal conditions, right? But we're going to kind of focus. I understand that it's a little bit different, but we're going to kind of focus on that idealness.
got it. Thank you.
Yeah.
Can I go to 5? Hello?
Yes. You had a question
Number
on 5?
Yeah, because I got an answer 20.35. So wouldn't you round up to 20.4?
Yes. Yes, you would round up, if it was 20.35, you would round up to 20.4. But again, if you're within 2 or 3/10 of a nautical mile in this plotting scenario, you're fine.
Okay.
But technically you are correct. Okay. So, how do I get out of this?
Just as long as it doesn't make you late for lunch.
That's right. You don't want to miss happy hour. Okay.
Make dessert anyway.
It is.
Okay, we're gonna go back to our PowerPoint. So now we're gonna bring our 60 D Street and time calculations back into our plotting courses and directions and plotting distances. And what we call this is dead reckoning, which is short term. I think originally it was called deduced reckoning, which is just a calculated position. And you'll hear me, maybe other people reference it to a DR. So dead reckoning is a DR. Your DR fix, your DR something or other. That just means it's calculated. So that puts you in that, ideal world, nothing else is affected. The only thing that we are putting into it is our vector of the direction we think we're going and our speed and time. So our distance, speed, time, and direction gets calculated into a position. And that's what we call our DR position. There's 2 ways DR positions are used. One for a backup for GPS or visual fixes. If for some reason you lose your GPS, you lose power on board, and there's no, aids navigation around you, you can start doing DRs to get a better idea of where you are currently. So if my last position was here and I was headed north at 5 knots, my calculated position would be somewhere over here. Now, is my calculated position there? Probably not, but it gives me a ballpark. It gives me a calculated position that I could say, yes, I'm somewhere around here. Oh, hey, maybe there's some shoals or some wrecks that I need to be aware of in the next 2 hours or something. So it gives you kind of, I got ahead of myself. It gives you a prediction. But first, I was talking about a backup. So if some in your electronic navigation systems will do this DR if it loses satellite or some sort of connection. It starts giving you a DR, and it might flash that calculated or DR across the screen of what it thinks you were doing from your past history. The other way is that it's great for predicting or projecting. So if you want to know, when am I going to make that turn? Is it like 2 hours away? Is it 30 minutes away? When am I going to make that turn? You can DR a calculated time of when you're going to make that turn using your 60D street. Again, this is just a calculated. Maybe there's a current, maybe there's wind, maybe there's all this other stuff. But the DR is just a calculated term using the ship's heading, or your course that you're trying to make, the speed that you're trying to do, and the time. So 60D street. We also use it for projecting out. It's very common on board to, anytime that you get a fix, then you put a DR position maybe a half hour out or an hour out. It's usually an hour out depending on where you are. If you're in congested waters, maybe you want to do a half hour or 15 minutes out. Just so you could say, okay, instead of looking at all this crazy stuff ahead of me, way, way, way far away, what's going to happen in the next 30 minutes? Or what's going to happen in the next hour? I want to predict what I'm going to see. Am I going to be crossing a traffic lane? Am I going to be rounding a point, or, should I be a lookout for a lighthouse, or, something on the beam? Can I get a good fix with these things? It gives you kind of a window of opportunity saying where you're going to be. And again, if you have electronic navigation tools on board, a lot of times they give you that little vector. So they'll give you a vector out from your position to say, and you can change that vector. In the next hour, you're going to be here. The next 6 minutes or half hour, whatever it is, it'll give you that little vector. I like to associate it with a lot of cars out there have those backup cameras, where it gives you a projection of where your car is going to be with the yellow or the green, yellow, red. And if you turn your wheel, that projected vector will turn as well. So either your electronic navigation can do that, you can calculate doing that. It's just a good tool to project where you think you're going. So you have better situational awareness, which makes you a better navigator.
But it's is the main differentiation, this is a form of determining where you are that's different from actually really determining where you are. In other words, so this is hypothetical or future, or if you're unable to do it accurately another way. Is that right?
Yes, yes. And we're going to go into a little hierarchy. I have a slide on that. But for dead reckoning, we need 3 things. We need a known position. We need a start point. So whether that's, hey, I left Newport, that's my start point like 5 hours ago, or, my GPS just went out and I have a last position 30 minutes ago, and now I need to start DRing. Whatever it is, we need a known position to start with. And then we need a course. We need a direction of that vector. And then we need our speed. So what is our projected speed that we are going to be making? And we use our 60D speed to use distance, to calculate our distance, and then we can get a DR position. And we're going to be practicing this on the chart. So hopefully it'll make more sense to you as we go. But those are the 3 things we need: a known position, your course, and your speed. And then we could use our 60D street to calculate time or distance. Okay, so dead reckoning, we have I have a very abbreviated little track line here. So we have WP, that stands for waypoint. That's a lot of what we use waypoint as a term, just as like a turning point or kind of like the intersection of what we're doing. So we have waypoint 1, then we have waypoint 2, and then we have a buoy. So if I mark a position, it's going to be this solid dot. I have a triangle, and I'm going to show you what all of those symbols mean. And I have a time of 0730, my course, my speed, so-and-so. Now, if I want to, most of the time, we, I'll go back. Most of the time, we put our DRs, excuse me, either at the top of the hour, every half hour, or at a turn, or, you know, at, say, waypoint 2 here, somewhere at the end of the line. So we'll want to get in practice of any time we plot a position, we want to project out where we're going to be at least to the top of the hour, maybe fully along the line. So if we were here at 7:30, where are we going to be at 8? So that's a half hour. If I'm going 12 knots, my distance using my 60D street would be 6 nautical miles. So I would plot a DR position right here. So a DR is going to be a solid dot with a half circle or a semicircle. And sometimes I like to think of it as a D on its side for DR. Yeah, crazy grief. So that's the symbol for DR. And then our time, we write at an angle to our course line, where our solid fix, whether we got electronic fix, whatever it was, we draw straight, if you will. The DR is going to be a half circle and on the angle, and that is giving us the information that this is a calculated position. It's not a, you know, for sure position. It's only calculated. So when do we plot these DR lines? The book, if you're reading the book, it says every half hour. And again, this plotting a DR is all dependent on where you are. If you're in the middle of the ocean, nothing around you, plotting it every hour is probably okay. If you are in very congested waters with lots of traffic or lots of islands all around you, maybe you want to plot it every 15 minutes or sooner than that. But on average, the book likes to say every 30 minutes. So when do we plot? Every 30 minutes, or if we change course. So if we change course, that vector is no good anymore. The vector has changed. So we need to replot our DR. If we change our speed, our vector has changed. So we need to replot our DR. That distance would have changed. And then anytime you fix your position or you pass close to an aid to navigation, so that's when you get that starting point over again. So in this recreational boating, if we pass close to a buoy or an aid to navigation, we can just say that's where we are and then project out from that point. So anytime you fix your position, you get a new starting point, that has more information. So then you project out from there. So that's when we plot our DRs. So this is a symbol for different types of fixes, and I also put it in a hierarchy. Again, well, I guess I'll talk about it and then I'll say my little spiel. So dead reckoning is your basic. It's just calculated position. It's just using 60D street and your intended course. So basic information. Your estimated position is using one more thing, either one LOP, and we're going to talk about LOPs next week, or one more piece of information, meaning you have a known set and drift or known current that you can take an account for and add that to your dead reckoning, which is just the calculated position. So your estimated position is just your DR plus one more piece of information. Then you have a running fix, which we have a whole lecture on. And that is if you have, it's kind of a combination of this DR and LOPs, because it's a running fix is if you have two LOPs at different times. So you've got a bearing or some sort of LOP, some sort of information at one time, and then you kind of DR for the time that you got the next one, and then you move your, you advance your other line to that one. So it's kind of a combination of the DR and two LOPs. Again, we have a whole lecture over it. We're gonna get into it, I promise. And then we have electronic fix, which is that triangle. So your electronic fix can be your GPS, can be a radar, any sort of thing that you're getting your position electronically. And then the dot with a circle is a visual fix. So that is, you have a bearing, a bearing, a bearing, and you get a fix. That's your visual fix. So if we're looking at the hierarchy here, dead reckoning is, you know, kind of that least reliable or accurate, if you will, but it's better than nothing. It's better than being, hey, I'm in the Pacific Ocean, hopefully. You know, it's just a calculated position. Then we have an estimated position that gives us a little bit more information. Then we have a running fix that gives us a little bit more information. And then we have our two electronic fix. Again, that's based on you're trusting the satellites and all of the electronics to give you right information, which nowadays it gives you the right information. That's pretty reliable. But so I might even switch this. There's more human error in a visual fix than there is in a electronic fix. But it's always good to check your electronic fix by a visual fix. And that's you trusting your eyes and your compass to get a visual fix. So that's the circle. My caveat on this is these are just fancy symbols, and you'll see me using these symbols, but this is like textbook, what I learned at the academy. It's in Bowditch. But what you want to do, you want to have a system that works for you and the people that are on your boat, your crew. Whether it's your family, it's your friends, it's whoever it is, you want someone to be able to look at the chart and understand what's on there. So if you drew squirrely lines everywhere, didn't label anything, and it just looks very confusing, it's going to be hard for someone to take over and let you rest or something. So you want to, you know, this is a DR position. It's not an actual fix. It was only calculated. You want to make that clear in some way without having to say it over and over again. So just using that DR symbol is a quick way to do that. It's just about, you know, having that communication within your crew so that you can pass it on. But again, this is a real fancy way of doing it. You don't have to do it this way by any means. I don't know, some people like it. Okay, oh, and then throwing in one here. I think in 2 weeks, we're gonna learn about a bow and beam fix, which I like to put right in between the dead reckoning and the estimated position. The bow and beam fix is kind of this quick and dirty shortcut that's a little bit better than the DR, but not quite an estimated position. So we're gonna go over bow and beam fix and running fixes, I think in 2 weeks. This is week 4. Yeah, I think in week 6 we do that. Okay, any questions? I know we covered a lot here.
So is the only difference on the symbol between the running fix and the visual fix that for the running fix, you actually write R fix above the circle?
Yes, you write R fix.
Okay, thanks.
Okay, so next week we're going to learn about more LOPs. We're going to go into how those LOPs form fixes and how we get those, and kind of dive into more details about the plotting. But right now we're going to take a 10-minute break. Let's come back at what do we have? About 8:05, and we'll start doing assignment 10. So assignment number 9 is just going to be homework for you guys. That is, I'll stop sharing. Assignment number 9 is, well, that's not 9, is just practicing 60D Street. So you don't need a chart or anything like that. It's just practicing a 60D Street formula. So we're not going to do that one in class, but you guys can do that on your own. And again, the answers are either in your answer packet or they're on the Google Classroom under answers. But right now we're going to work on assignment number 10 on the training chart, 1210 TR. So let's take a little break, refill your coffee, whatever you need, and we'll come back at 8:05.
Is it 20:05?
That's right, 20:05. You got it, Elizabeth. All right, I'll be back.
Can old people go to academies?
Yes, they can.
Yeah?
Yes, it is. The California Maritime Academy, the one that I went to, is part of the CSU system. So it's a 4-year program, and you get a bachelor's degree and your third mate unlimited license and your 100-ton license at the end of it. But you can, I knew some people do it in 3 years, but that's if they had other college courses along the way. So you can still work your way up that system. But a lot of times it's called hawse piping, where you start as a deckhand or an AB or something on board. AB is an able-bodied seaman, and kind of do time that way, and then work your way up to third mate, do time, work your way up that way. Both, I've met some really great hawse pipers, and I've met some really great academy grads. Those are kind of the 2 ways to work your way up. With the academy, you know, you have student debt. It costs money or scholarships to go to an academy, but you do get your bachelor's degree, which is a great backup. And then you graduate in 4 years as an officer. So you start getting that officer pay. Where if you start as an ordinary seaman or able-bodied seaman, you don't have all of that student debt because you didn't go to an academy, but you have a much lower pay for maybe 5 or 6 years before you can start working your way up. Those are kind of the 2 differences between hawse pipe and academy. But yeah, I've met both great academy grads, great hawse pipers. I didn't even know about it before I went there, but this OCC has a really great program. What is it called? Professional Mariners program that really trains you to get a good deckhand or ordinary position on board. And I think you get your associate's degree with OCC. It's part of the OCC curriculum. I have to look into that more. I don't know exact details on it, but yeah, it's a really great program that OCC's has. And we're getting that simulator across the highway that's going to make it even more exciting.
Ooh,
Okay. Cool.
thank
All right,
you.
well, let's see. Where are my numbers? Okay, so we are on assignment number 10. Oops. There we go. This. Okay, so we are on the 1210 TR chart. We have assignment number 10 and our plotting tool. So you can use, I know I had them, your dividers or a compass, triangles, parallel rulers. Just curious here so I can do a better job of demonstrating. Who here is using the parallel rulers?
I am.
Okay. Maybe 2 or 3. So some people using those. Who is using the roll plotter? Okay. Couple. And who's using triangles?
Right here.
I'm using the triangle.
Okay, so we're kind of spread even in our. So I will work on all 3 of them.
Yeah, it seems like depending on the problem, if you choose your tool, you can save a fair amount of work sometimes.
Yes. There are little shortcuts that we are going to be learning along the way. Or I try to teach you the basics and you kind of find those shortcuts yourself. Okay, so let's get started. Assignment number 10. We are using the 1210 TR chart. And we want to be as accurate as possible. Again, this is practicing those course and distances that we've been plotting. And then we're going to add in our DRs here. So we have at 820 part Breton Reef light, and it gives us the characteristics so we can correctly identify it. Hopefully we're familiar with Breton Reef light by now. So here's our Breton Reef light. And I had a pencil 2 seconds ago. We'll go with this one. It's a little dull. Okay, so we were at Breton Reef flight at 8:20. So I'm going to put my time there. Breton Reef flight at 8:20. You set a course for Buzzard's light. Buzzard's light is here. So we're going to set a course to Buzzard's light at a speed of 6.5 knots. We're going to plot our true course, and then we're going to plot in our DR lines. So I'm just going to kind of put that to the side. So plotting a long line, we can either use a ruler. So our ruler here would go from Breton Reef to Buzzards, or we could extend either your roll plotter or something along the way. There it is. Your roll plotter, your parallel rulers, just kind of extending it. Same thing with the triangles. I kind of put a little extender. So I have the 2 lights lined up. And again, when I am drawing these this line, I always want to draw it on the same tool. So I'm going to switch this one so I can see it without standing up and messing up my camera. So I have the light there, light there. Okay. So now I can see that my light is touching the line here. My light is touching the line here. So now I'm going to go to one triangle. I'm going to draw in my line. And then I'm going to move the triangle with another triangle, but always draw off of this top one. So I'm going to move this along. And always draw along the top triangle. You don't have to do it that way, but I find it more accurate than switching from one tool to another. You kind of get a broken line, and you want that line as straight as possible. Okay, so now that we have our line, we want to know what the course is. If I'm going from Buzzard's Reef Light to, or Breton Reef Light to Buzzard's Light, I want to know what the course is. If I'm using the triangle, I put that long side of the triangle, that black line, right on the course that I have in question, and it's crossing two meridians, a meridian here and a meridian here. I could use either one. So I line up that black line on it, and then I line up this focal point on the vertical line. So I line that right up on the vertical line, and then I'm going to read the number down here at the bottom. So if I'm going this way, that's give or take 90 degrees, right? East is 90 degrees. So give or take 10, 20 degrees from 90. So when I'm looking at my numbers, I'm in between 90 and 100 instead of 270 or 280. So I have 96 degrees as my course. I'll show you another way. With the roll plotter, you have your compass rose right here. It's real close. So you line up that black line right on the line in question. Then you're going to push down on that metal bar nice and even. And now you can roll it or parallel it wherever you want. I'm going to put my pencil in the center of the compass rose. I'm going to draw my little line, and I get 096 right there. Same idea with the parallel plotters. I line up that black line right on the line we're looking at, and then I parallel down using the shifting of weight on either ruler till I get to the center of the compass rose, and then I could read what my course is. So my true course was, what do I have, 096. So now I can write on my line, I have a course of 096 degrees true, and I have a speed of 6.5 knots. So if I left here at 8:20, I want to plot my DR for 9, 10, 11. I want to plot it on the top of the hour. So if I want to plot one at 9 o'clock and my last known position was at 8:20, that means my time is going to be 40 minutes. So my time is 40 minutes. My speed is 6.5. What is the distance traveled? That's my question. So I use my 60D street. I'm going to do the circle here. D is my question mark. Speed is 6.5. Time is 40. So I use 6.5 times 40 divided by 60. I get a distance of 4.3 nautical miles. So now, can we still see this? I don't know. Okay. 4.3, I'm going to find my dividers, and on my side here, I'm going to find 4.3. So I'm going to do 1, 2, 3, 4.3. So from Breton Reef, of course, I wrote my numbers right where I'm going. Erase that a little bit so it's clear. trying to draw it big so you guys can see it with this zoomed out screen. Course, 096, speed, 6.5. Okay, so my 4.3 nautical miles is right about here. So I'm going to make a DR symbol and have that as 0900. So I have my 0900 DR. It's right underneath that area 2 note B. That's where I have mine. And then the rest of the DRs are really easy because nautical miles per hour is your speed. So if I'm going 6.5 nautical miles in 1 hour from 9 to 10, I would have traveled 6.5 nautical miles. Just like on the freeway, right? If you're going 60 miles per hour, in 1 hour, you would travel 60 miles. The same thing, we're doing our speed is 6.5. So from 9, we have a DR here for 10. And I can't go quite to 11. So 11 is going to be somewhere over here. So I'm going to have to calculate what my ETA is. And I think that's a question. But this is just our basic. We departed at 8:20. So at 9 o'clock, I should be next to this buoy A. At 10 o'clock, I don't have anything quite next to me, but I would have passed some sort of point here. And then I'd get to Buzzard's Light around 11, a little bit before 11. But I'm sure we're going to calculate our ETA. Does that make sense how I plotted those DRs so far?
Mm-hmm.
Okay.
Yes.
Okay. Thank you. Okay, so next, we have what is the distance of this leg of the cruise? So what is the total distance? So it's a longer distance. My dividers aren't going to reach all the way. So I'm going to find 5 nautical miles on my dividers. And then I'm going to walk the dividers. So I start on Breton Reef, and I go 5, 10, 15, and a little bit. So we have 15 plus whatever this is that I measure here. 15 plus about 1.1 or 1.2. What is it? Can't see up there. I think I have 1.1. So I have 15 plus 1.1 would give me 16.1 nautical miles. My answer on the answer sheet was 16.2. Not a big deal. If you're within 2 or 3 tenths, that's fine. Now, with this information, this was my distance. What is my ETA? So we'll go back to this. If I have a distance of 16.1 nautical miles, a speed of 6.5 knots, I'm looking for my time, and my departure was at 8:20. So what is my ETA? That's my question mark. So I need to know what time is. So I plug this in and I get 60D divided by S gives me T. 60 times 16.1 divided by 6.5 gives me T. Let's see, what do we get here? We get 1 divided by 5 gives us a time of, let's call it 149 minutes. 9 minus 60 minus 60 gives us 2 hours and 29 minutes. So if that's my transit time. So if I depart at 08:20 and I have a transit time of 2 hours, 29 minutes, I'm gonna have to add these. So I always start with the minutes. I have 20 plus 29, so that gives us 49. And then our 8 and 2 gives us 10. So my ETA is 10:49. My answer sheet said 10:50, totally fine. Put that to the side. Okay, so 10:49. Okay, any questions on how I calculated that ETA? We're doing all right with that?
I have a question.
Yeah,
So
go ahead.
last week it was all, you know, I got kind of freaked out a little bit about like where there's variation and there's deviation and there's magnetic, and so we're just doing true.
Yes. So so what we learned last week is all compass error. And this week we're kind of putting that aside and learning a new topic of DR and 60D Street. And then next week we're going to put both of those, that compass error and that DR together.
Yeah.
If that helps.
Okay.
So yes, this is completely different from what we did last week. We kind of, I mean, we didn't forget about it, hopefully, but we're putting that aside and we're learning a new topic. So yes, everything is true, made good, or we're going to see that it's not quite made good, but everything's ideal right now. Yeah.
Got it. Thank you.
Yep. Okay. Okay. So then it says plot and label the 0900 and the 1000 DR. Okay, so I already did that. I got a little bit ahead of myself. Okay. How far would you have gone by 0900? We had calculated that. I erased it. But it was 4.3 nautical miles. We did our 60D Street. And then how far would you have gone to 10? So to get that, if to 0820 to 0900, I went 4.3 nautical miles, and then 9 to 10, I go 6.5. My total distance so far would be 10.8 nautical miles. That makes sense? Is that all right? Not really a shortcut, but we're just kind of putting together the pieces here. Okay. Okay, now it says you arrive along Buzzard's Light at 10:35. So we cruised along and we got here at 10:35. Now, when did we predict we would get there? 10:49. So by just looking at those two numbers, did I go faster or slower than I had predicted?
Faster.
Faster.
Faster, right? I got there in a shorter time. So now it's going to ask us, determine the speed made good for this route. So, or this leg. So with these two times, I know the distance, right? Our distance was, I'll write this out. My distance was 16.1 nautical miles. I now have some time. I'm looking to find speed. So to calculate time, I need to get the difference between my arrival time and my departure time. So we always put the later time on top. That's going to be that arrival. So we got there at 10:35. We departed at 08:20. What is our time? So we always start with the minutes. We have 15 minutes left there. And then we have 2 hours and 15 minutes. So we want to convert that into minutes. So we have 135 minutes. That was 120 plus 15. So now I can use my 60D street to get what my speed was. So I have 60 times D divided by T gives me speed. 60 times 16.1 divided by 135 gives me speed. Let's get my calculator out.
7.2.
What do you guys get?
7.2 knots.
7.2?
7.15 to 7.2.
7.15, 7.2 equals speed. And that is faster than our 6.5. So that double checks our little common sense check, right? If we get a different number, then we'd want to recheck our math. So we looked at the two numbers and I could see, yes, I think I've gone faster than 6.5. Let's calculate it out. So we got 7.2 knots. Okay, any questions so far? Okay, we're gonna move to, bear with me here. We're gonna go from, where we're going? We're gonna do from here to Gayhead. Okay, so I think here. Let me focus this a little bit. Okay.
Where's the deepest water you've sailed? Oh my God.
Okay. So let me bring this closer so you guys can still hear me. Hold on. Okay. So we were here at Buzzard's Light. And we take photos, we fish for a little bit, maybe have a lunch or something, and then we depart here. So again, if we're near or close to a aid to navigation, we call that a position in recreational boating. So we're going to depart Buzzard's Light at 10:56. So we're going to depart Buzzard's Light at 10:56. And we're headed for buoy 29. Here's our buoy 29. It's at the northwest end of Gayhead. So we have buoy 29 and our buzzard's light. We're going to draw in our line. And the first question is, what is the course? So if you have your roll plotter, you put your black line on the line and bring it down to the compass rose. Draw in your line. Let's see here, I got 104. If you have your triangle, you put that focal point on a vertical line, the dark line on the long side of the triangle on the line in question. So I'm just lining it up there. And then we have, you read it at the bottom. Here's 100, 105. So we can read 104 as our true course. Parallels, line up that black line and move it down to the compass rose and draw in your line. So we have a course of 104 degrees true. Does it give us a new speed? We have a new speed of 5.6. So we're going even slower than our old speed. So we are slowing it down. Or we're trying to slow it down. Okay, label the time of departure and label the true course and speed. So that's what I just did there. What is the distance of this new leg? Okay, so let's see. I don't think we're going to be able to reach. Oh, no, we are. Okay. So one divider, or one end of the divider is on the other, one on the buoy. And then we can go to the side. Oh, I'm zoomed in so you can't see my side. What do you guys get?
7.9.
Wait. What did you get?
Well, I measured on the triangle. 7.9 nautical miles.
7.9. Yeah, or about 8. I got 8. 7.9.
Yeah, 7.
Sounds good. 7.9. Oh, my true course was 104. Okay, so using that distance, I'm on the light over here, but that's okay. There we go. Try to tilt it a little. Okay, so our distance was 7.9 nautical miles. Our speed, we have a new speed of 5.6 knots. What is our ETA? That is our question, right? What is our ETA to buoy 29? So we're looking for time. So we can do, let's do magic circle. 60 BST, 60, 7.9, 5.6. We're looking for time. So we do 60 times 7.9 divided by 5.6. And what do you guys get for time? Or do you want me to do it on a calculator?
84.6 minutes.
All right, 84.6, let's call it 85. So I'm going to convert that to hours and minutes so I can apply it to my other time. So I have minus 60, and we get 25. So 1 hour and 25 minutes. So I had a estimated time, or my time of departure was 10:56. Then I have a transit time, so I'm adding 1 hour and 25 minutes. I'm gonna add my 56 and my 25s. That gives me 81, but 81 doesn't work, right? We can't have 81 in a time. So we have to subtract 60, and that gives us 21, and we're carrying the 1 on the hour side. So we have 10 plus the 1 and another 1 gives us 12:21 as our ETA. That makes sense. We're practicing those time conversion skills and adding and subtracting.
Could you convert 1056 to military time first before you did that?
10:56 is already in military time.
Oh, okay. Right. Gotcha.
So that would be 10:56 a.m. because
Okay.
it's not in that big number.
And now if it was after noon, then you'd have to convert it to military time at that point before you could start the equation.
Yes.
Okay. That makes sense.
Okay. Our next question here. We have, what is the deepest water you sailed over on either leg of this cruise? So this is kind of a hunt and find what the deepest sounding you could see. Anybody
It's the
find it?
109.
109. So we have right here, our course line kind of goes like this. We have a 109, a 102, 68. Oh, and we have a fathom curve, kind of running like that. So 109 is the deep spot, and then all around it is a little bit either 109 or shallower. So I called the deepest spot that our boat is going to go over. Where's my little boat? As our boat cruises over, it doesn't quite pass that 109. So I would have called our deepest point 108. Again, that's my new detail. 109 is a fine answer, but that's why it says on the answer sheet 108, because we didn't cross over the 109. We crossed, okay.
You've got 122.
I put 120. It's 102. Okay, I'm confusing you guys. I'm sorry. It's going shallower. The line where our boat is. Okay. Any questions on that?
Why is that other line important?
So this line is the 100 fathom line. So it's saying anywhere along that line is 100 fathoms. When you see those fathom lines really close together, you know that it's a steep curve, and you might get some weird eddies or a lot of fish or wildlife or something when it's real steep. When those fathom lines are real spread out, it's a much shallower slope, if you will. So maybe some calmer water. Again, if it's super deep water, maybe it doesn't make that big of a difference, like it is off the coast of Long Beach here. But, yeah, the fathom lines can give us an idea of the shape of the sea bottom.
Where's the fathom line on the chart? Can you show me?
Yeah. It is this line right here.
Got it. Okay.
Oh, the fathom line is 90. I read that wrong. So you could, if you follow the line, 90, and then we have a 60 fathom line. So I'm sure we have a 30 somewhere, but yes, that's that fathom line. Okay. Now, where is the deepest spot? So here we're going to practice our latitude and longitude again. So if you were to say that 109, that would put you over here. But the deepest spot our boat would pass would be on our track line, ideally if we're on our track line. So I'm going to put a little dot on our track line right below that 109. And now I want to find my latitude and longitude. I'm pretty zoomed in here on the chart, but I like to plot in my longitude and latitude. I put my pencil on my position, line up, I have my triangle upside down, line up my triangle. There's my longitude line. There's my latitude line. And now I can use my dividers to measure. I'll bring that all the way to the side. What do you guys get? 23.4. $41. I'm just right past the 71 longitude. So I have 071 and 0.3 minutes west. So that is my latitude and longitude for that deepest point. I didn't get a time or DR, but you can. The worksheet doesn't ask for that. I guess it's just an exercise of always looking along your line and practicing your latitude and longitude skills. Okay, oh, I'll leave that there, sorry. I got the weird reflection with the light. All right, any questions? How are you guys doing so far? All right, we're gonna move on from, we got to buoy 29. At what time did we get to buoy 29? At 12:15. So if we got to buoy 29 at 12:15, what was our speed made good? So we thought we were doing 5.6 because we were slowing down. But what is our actual speed from time to time? And we know the distance. So get our whiteboard out. We have a distance of 7.9 nautical miles. That was the distance from the light to the buoy, 7.9 nautical miles. We want to know what our speed is. That's what we want to know, what our actual speed was. And then for time, we have two times, like clock times, and then we need to know what the minutes are. So we had our arrival time of 12:15, and we had our departure time of 10:56. So how many minutes are in between that? So again, we're practicing those time converting skills. we start with our minutes. We can't do 15 minus 56, so we have to borrow, and that becomes an 11, and this becomes 60 plus 15. So that would be 75 minutes. So we have 1175 instead of that 1215. So now we can do 75 minus 56.
19.
Gives us 19. And then we have 11 minus 10 gives us 1. So if I convert that, I get 79 minutes. So I can use my T is 79 minutes. What is my speed? Do another color here. Oops, there we go. All right, so 60 times D divided by T gives us speed. 60 times 7.9 divided by 79 gives us speed. We get
6
knots is our speed. So we are going a little bit faster than whatever current was pushing us along the first time, it's still pushing us along this time. So hopefully we're in the Vineyard Sound here and not less affected by this current that's pushing us. But yes, our speed made good was 6 knots. So you guys kind of get how the boat speed and speed made good are two different things, right? We think we're going 5.6, and a lot of times that it depends on what kind of boat. And for a sailboat, that's very hard to calculate, right? What speed you think you're going to go. Sometimes on power boats, you might have something that says, at 50 RPMs, you do 1 knot. At 100 RPMs, 2 knots, or however, like per RPMs. On those big commercial ships, you have dead ahead, ahead, slow ahead, and at each RPM, you have a different speed or whatever number it is. So that calculated speed is kind of that ship speed or by wheel, sometimes they'll say. So what does the boat think they're doing versus what it's actually doing over ground or made good? There's going to be two different numbers. Okay, off my soapbox. Okay, so now from buoy 29, we're going to head in to the pond here. What is this? Minisha Pond. And we're going to go to buoy 1. That's that little black buoy there, buoy 1. So we just want to join. First steps first is you draw your line from point A to point B. And then look at your line. What am I going to be crossing? I'm going to be pretty close to this can buoy number 1, but hopefully I'll pass to the north of it. And then I might get close to some shallow water here. But if I'm going into this pond, then I'm probably okay. Excuse me. So our first question is, what is the true course? So we have all of our nav tools again. Triangle, you just line up those 2 buoys and the focal point. I like the triangle because you don't actually have to slide it or move it anywhere. You can just read it. I have a course of 096. With your parallels, same thing, line up your 2 buoys. Bring it down to the same compass rose. Always go from the center of the compass rose. And we get 096. And our parallel, or our roll plotter, excuse me. line up the line, and bring it down to our compass rose. All right. So we got our true course of 096. And then it asks, what is our ETA using our original, our boat's speed of 5.6. So they didn't ask us this time. They didn't hold our hand on this. They didn't ask us what distance was, but they're asking us what is the ETA from this spot to this spot. So my speed is going to be 5.6. That's what my boat thinks it's doing. And then I need to calculate, or I'm looking for time because I'm looking for my ETA. And I need to calculate what my distance is. So let's use our dividers. What distance did you guys get?
4.2.
4.2, 4.3. Let's use 4.2. So now we can do, call it distance equals S times T divided by 60 equals 5.6 times 4.2 divided by 60. What does our distance equal? No. I'm doing this wrong. Why? It's not even on the board. Someone's got to holler at me when I start getting off on a tangent. Okay, we're looking for time. So we have 60D divided by speed gives us time. 60 times a distance of 4.2 divided by a speed of 5.6 gives us time.
45 minutes?
What did you guys get?
45 minutes?
45 minutes. So if we departed at 12:15, when are we going to get there?
Just in time for lunch.
45 minutes. Carry the 1. 1300.
Made our lunch date.
Yeah. So we get there at 1300. And that's a DR because it's just calculated. So I would have written it diagonally. Okay, now if we got there at 1300, what is the total elapsed time between Brenton Reef and Minishma? I don't know how to say that. Pond. So we're practicing our time calculations. So we had 1300 was when we arrived, and we originally departed at 8:20. So how long has this transit been? That's including our little fishing lunch photo op at Buzzard's Light. So we have 1300, which was our arrival minus our departure. We start with the minute side. We can't do 0 from 20, so we borrow. And we get 60 minus 20 gives us 40. 12 minus 8 gives us 4 hours and 40 minutes as our total leg of, or total cruise time. All right. So, let me see you guys big here. How do you guys feel about that so far? Doing all right? Okay.
Good.
Okay. Starting to make a little sense? Good. I hope so. So the homework is to do, again, just that 60D street practice. You don't need a chart or anything for it. And the answers are on the Google Classroom. But again, do that common sense check. And if you get something wrong, you're probably divided instead of multiplied or vice versa. So always do that double, common sense, does this make sense check. Next week, we're going to combine that compass error and plotting and getting a fix by bearings. So we're converting our compass bearings into true so we can plot them on the chart. And then from that point, we're DRing using our 60D street. So we're kind of building those skills that we are practicing right now. So definitely keep practicing. If you guys have any questions, let me know. That's all I got for you guys tonight. I will, this is being recorded, so I will post this. I start downloading it tonight, but it takes a long time. So hopefully by Friday or Saturday, I'll have it uploaded on the YouTube channel. The assignment number 10, if you guys want to do this one again, it's again on this recording, but I also have a tutorial on it. And that's all I got for you.
Thanks.
Thank you.
Thanks, Captain.
Thank you.
Thank you.
All right, you guys have a good one.
See you.
One question.
Bye.
Yes, go ahead, John.
On assignment 5.
Assignment 5, yep.
Yeah, this is the chart compass correction.
Yep.
I noticed that, like on number 1, they're telling you that you're taking a bearing using the ship's compass and, well, no, excuse me, on number 2, yeah. So anyhow, you're taking your bearings from the ship, and I noticed that the deviation and the variation is the same for all 3 conversions, for the heading and the 2 bearings you take. So when you does that assume, you say that you're using the ship's compass to take a bearing, wouldn't you actually have to turn the ship and point it towards a different location in order to get an accurate bearing?
So that is one way of getting an accurate bearing, but on some ships, the compass is flat. I'm going to show you a picture here of how basically how the question was designed, of how they're getting a bearing. Bear with me real quick. We're working on another class here.
I assume the boat is actually just facing the same direction all the time, since the deviation is staying the same, right?
Yes, yes. Okay, so you see, so this is kind of different compasses that we can have on board.
Yeah.
We have a gyro compass, which is up here, and this is a gyro repeater. So this is how, this one on the bottom right, if you line up one line with another, there's a mirror on the compass, so it can give you a very accurate bearing using the ship's compass.
Okay.
Again, using like the bubble compass, which is what most of the recreational boats are going to have, over on the left, that's going to be very hard to do, practically impossible. You're either going to be using a handheld compass, or you would actually turn the boat to be dead ahead, pointing at whatever you want to get your bearing off of. And then your deviation would be for that bearing. So your deviation is always with the heading. So if your heading is the same for all of your bearings, your deviation is going to be the same for all of your bearings.
Okay, but then in number 3, when you were using a hand bearing compass, there was no deviation included. Just the variation was used, but the deviation was not included in the calculation. Why was that?
Correct. So that is the way that U.S. Sailing does their calculations. If you are using a handheld compass, they're saying that that handheld compass is pointing directly to the magnetic North Pole, and there's no deviation at all, or the deviation's so minor that you don't need to count it. I personally don't agree with that, but that's the way that U.S. Sailing teaches the course, and that is the certification you get at the end of this class.
Yeah.
So for handheld compasses, there is no variation, according to U.S. Sailing. But for the boat's compass, there is a deviation.
Okay, so but if you had a handheld compass, it would be subject to the same, the engine and the generator, the exact same thing. You're probably standing in the middle of the boat next to the main compass, so it seems to me it would be the same thing.
I agree with you. I don't know. Hey, Captain Ron, are you listening to this conversation? No, he's not.
Yes, I am.
Oh,
Yes, I am.
you have any input on why there's no deviation on handheld compasses according to U.S. Sailing?
The reason is that although there is deviation, you can't calculate it because the compass moves around, whereas your shipboard compass is in place. So if you're walking around the boat, you got various deviation everywhere. So you don't, what they say is go someplace where it has the least amount of magnetic draw. I've seen sailors climb to the top of the mast to take a bearing, or go up in the bow pulpit, someplace where it has the least amount of magnetic influence from your boat. So there is actual deviation. We just can't calculate it because you're walking around with it, whereas the ship's compass is fixed. So we know it's drawn what the influence is at that position.
Yeah. Okay. All right. Thank you.
All right, cool.
Bree, I just had like a housekeeping question.
Yeah.
Do you erase after every time you do a new trip? Do you erase everything on your chart, or do you get a new
Yes.
chart? Okay.
Yes, I do.
Okay.
So, you know, there's different, you know, rules depending on what type of vessel you're on.
Right.
You know, like you must keep a log for at least 3 years or something if you have passengers, that kind of thing. So ideally, your log is so detailed that you could, you know, produce it on a chart, that you don't need that information on the chart, that you can just erase it.
Okay.
Again, that goes into good log keeping versus just writing information on a chart and not a log. If you were required to keep that, you might work on that, but most recreational boaters are just going to erase. And sometimes if you're going from one place to another very frequently, I did it all the time when I was up in the Puget Sound, and we were going outside of the Puget Sound and then back down to Seattle. There's a lot of different courses and legs. I would even draw that in pen, which is like, you never want to draw anything on pen, right?
Right.
But I didn't, every time, I didn't want to erase that and then draw it and then erase it and then draw it like every single time. So I would draw it in pen and then put magic tape. And it doesn't work with Scotch tape. It has to be magic tape. I don't know why. But we can put our positions and stuff over the tape. And then at the end of the voyage, I would just take the tape up and it would cleanly come up. Again, that was magic tape.
Right. Okay.
And to be clear, you get magic tape at the same place you get the little magic circle thing at?
Yes, exactly. We're using a lot of magic.
Okay, I know that it's probably a silly question, but I'm just like, well, do you keep getting a new chart every time you go somewhere?
No. You always want to use pencil so you can erase. And I would definitely use the white erasers. If you use the pink eraser at the end of the pencil, that's going to mark up your chart. So I I don't know where mine is though. That white rubber eraser.
Okay, thank
Yeah.
you. Thank you.
No problem. All right. Well, you guys have a good one.
I had one more question. So
Yeah, go ahead,
I assume that airplanes are also using nautical miles since they always report their speed in knots. Are they also using the same navigational coordinates essentially?
I think so. Sometimes we have pilots in class. Are there any pilots still talking? I know pilots do use deviation, so they calculate their variation and deviation and magnetic headings. I had one pilot in class talking about that. I don't know about latitude and longitude positions. They must have latitude and longitude and altitude. But I am not positive on that.
Yeah. Okay, just wondering. Yeah. Alrighty, well, thanks for your help.
Cool.
Thank you.
All right. See you guys.